Hi, I am Farah. Together with my teammate Shehryar, we will be presenting about our ETP project that was conducted on September 2022. This project has got recognition from the judges, and we decided to participate in SEDEX50 with this project. The idea of making this prototype comes from the focusing issues and problems around the world, such as lack of electricity supply at the rural areas, and this caused difficulty for them to obtain enough electricity supply. Second, in our current economy, there are raising of electricity bills, and this affecting some of the users, and they have to cut the electricity usage. And also, the idea of using renewable energy, this can combat the power energy transmission that can cause transmission energy loss. So we have come with the ideas of generating power using renewable energy. Rural area filled with natural resources such as wind and water. So we can place the turbine at the river or stream nearby, and it can generate electricity by using kinetic energy. To increase the function of the turbine, we can use them during windy day, and it can produce electricity. So combining with these two functions, we can conclude that creating a bifunctional turbine would be useful for the rural residents. By doing this, three objectives could be achieved: supplying energy to underdeveloped area, reduce electricity costs, and also providing clean and sustainable energy for a long term.
This is the design concept for our project. Starting off with the sizing, we made the project purposely very small so that it could be portable and it wouldn't be a hindrance to people whether they're carrying it in a car or a bike or by hand. Next up, the turbine. The turbine is the main component that helps produce electricity. The one in the prototype is not the finalized design. It's very inefficient and it doesn't generate as much electricity as we'd like it to. But for a proof of concept, it shows that the project works and it is a viable option. Next, the kinetic supply energy. For this, we use a coupler to hook the turbine onto the electrical components. The electrical components aren't the best either. They're only there to provide proof that this concept works. They don't produce the most amount of electricity, but for basic showing purposes, they do the job. The plan is to upgrade the electrical components so that they produce more electricity that is usable. The body is made out of a PVC pipe with a diameter large enough to fit all the components in it, but be small enough to again be portable. For the output, we're using wires that can be connected to a battery, or they can directly be connected to an electrical component that you want to use. The base on the prototype is not finalized either. It's only there to support the product and display it to the invigilators. The materials used were per spec: PLA filament body, PVC pipe, brass coupler, dynamo, rechargeable battery, and cables. In the finalized version, we hope to improve on the build quality and the performance of the product, so it's a more viable option for people who would look into buying it. Then we achieved a weight of 5 kilograms, which we believe is fairly portable, but the max voltage that we got was 3 volts, which is not enough. The problem statement that we had was that rural areas tend to be based in jungles and terrains that are difficult to access, which takes them out of the reach of electrical grid. So we decided to make a product that would solve that issue. You wouldn't need expensive electrical grids to be planted in areas that don't really support the infrastructure too well, whether they be too hilly or too low-lying, which could cause floods regularly and stuff like that. So we decided on making a small generator that takes all the downsides of these areas and turns them into a positive. So with our product, the goal was that it could be operated on wind energy and hydro energy as well. Say if you live in an area which has a stream or it rains regularly and water flows downhill, you can place the generator next to the water and it will spin up the turbine and produce electricity. Or if you live in a really hilly area, there's going to be a lot of wind, you can just place it and the wind will turn it and you can have electricity. The reason for this was that at the end of the day, people have families wherever they live. So for them to be able to charge their devices or get electricity for lighting, if they want to study at night, they can use energy generated from this to power a lamp, or they could charge up their phones and talk to their loved ones that they can't really meet up with. Taking all of these into considerations, we wanted the product to be portable and produce usable electricity. Right now, the results are a little underwhelming, but we firmly believe that with upgraded components and a better design for the turbine, we should be able to achieve the results that we were hoping for. We obviously can't reach the same results of an electrical outlet in a house or something, but we can still achieve results similar to what a power bank would provide, given that with a power bank you still need to charge it, but with our product you can let nature charge it and produce electricity for you. And with our product we're not damaging the environment either, and that was also something that was important to us. Now, given that power banks already exist, how can we say that our product would have a chance at being a viable option in the market? We conducted a survey for that, and we found that a majority of people said they would like to have a product like this, with the second most common answer being a maybe. Only 2 people said that they don't have any need for this product. Our goal was also to make it very affordable, so it doesn't matter how strong you are financially, you will be able to afford it. The components that we use on the prototype ended up with a total price of 160 ringgits. That is not a lot. If you want a good power bank, that will cost you around the same. So our thinking is that if we make improvements to the product and the price doubles, it's still 300 ringgits. 300 ringgits for a device that you can use to charge your devices or power your devices. For that sort of use, with a price of 300 ringgits, we believe that we present a very strong case of why you should go with our product. You don't necessarily need to be someone living in a rural area. You could be going camping, you could be going on a trip, and if you're worried about not having enough electricity to charge your devices at the end of the day, you can take one with you. You can just place it down, and overnight it will do its thing, and you will end up with devices that are fully charged by the morning. Depending on the type of improvements we can make to the finalized product, we could maybe even get the electrical supply to be high enough to charge multiple devices and run multiple devices at the same time. That, I believe, would be another substantial bump in the popularity of our product and allowing us to reach a larger market. If it ends up being too big, we could alternatively make a smaller version exclusively targeted at the market of people who go camping fairly often or travel a lot, so that it takes up less space and it provides them with the basics of keeping their devices topped up. And we could have a larger version for people who don't travel a lot but still need electricity in their house. So we believe that our product will be able to carve its place in the market.
As the project is a so-called prototype, of course there are some improvements that can be made in the future to increase the efficiency and marketing purpose. As you can see from the previous video, the blade was made in flat shape and from a press base. So to increase the efficiency, we can change the flat blade into an aerodynamic shaped blade to increase the force exerted on the blade and produce high velocity for more kinetic energy to produce high voltage of electricity, and this complies with the Bernoulli principle. Second, we can use a high durable material such as nickel superalloy or titanic superalloy to withstand the high pressure of strong current, water, and wind. And lastly, we can add more fins on the impeller of the bigger turbine, so more and higher electricity voltage can be produced. Overall, this project complies with the Sustainable Development Goal SDG7, which is providing affordable and clean energy. Also, this project aligns with the mission to achieve net zero carbon emission by 2050. So that's all from us. Thank you for having us.